All right, we are solving systems of equations with three variables. So it is going to take a little bit more time. So if you have three variables, you are going to have three equations to solve with. Now we're going to do some work to collapse them, and you can do whatever you want. But sometimes there's easier combinations than others. So step one is we're going to choose any two equations and eliminate one variable from those. So you can pick, I'm going to pick the first two equations to work with. So I'm picking the first two equations. You could pick any ones, especially if something eliminates easily. So I'm going to just take a minute and rewrite this as x plus 2y. I'm just rewriting the equations to get myself organized. You don't have to, but I am recommending that you write your z's with a line through them so they don't get confused with 2's. That's just how I do it. So I am taking 2 out of those 3 equations. And what I'm going to do is I'm going to eliminate one variable from these 2 equations. So we're doing the elimination method. Now, why did I pick equations one, the first 2 equations? If I use my elimination method skills, do you see that the 2y and negative 2y cancel out? So that's why I chose those two. Now, if that didn't cancel out on its own, then I would have had to manipulate something. All right, is that focused now? Or not? Is that focused? Okay. So I am left with 3x minus, there's a 1 there, right? Minus 2z equals 5. So I have basically taken it from 3 variables down to 2 by eliminate the y variable. So that's what we chose to get rid of. Now, the second step is to choose 2 different equations and eliminate the same variable. So you could mix and do equation 1 and equation 3, or equation 2 and equation 3. You need to basically pick one of what you've picked and then the third equation that hasn't been used. So you can do what you want. I'm going to pick equations, the second and third ones. So I'm going to just take a quick second and rewrite those in the form they were, and then we'll make any adjustments we need to. And again, once you get used to this, you can put some steps together. I just want you to see where this is coming from when we do our first one. So I'm focusing on these 2 equations. Now, if we eliminated y up here, I need to eliminate the y from here. So if I go through and I add, as this is, will the y's cancel out? No. So just like we did with the elimination method of a system of 2 equations, I need to come in and multiply everything in the second equation by 2. Because I already have a negative 2y, I need this to be a positive 2y. Now, just for good measure, I'm going to rewrite both equations. I'm going to rewrite the first one. Again, you can skip some of the extra writing. I'm doing it to make sure we see it. And then I'm going to double everything by multiplying it by 2 here. And don't forget that you have to multiply everything on both sides. Okay, now, if I come in and add, our goal was to cancel out y. So whatever we chose to cancel out in the first 2, we are going to cancel that same idea. So we're only left with 2 variables. So I'm left with 4x plus 5z, don't forget there's a 1 there, equals negative 1. I'm not sure if you see it yet, but I basically took these 3 equations with 3 variables and I brought it down to 2 equations with the same 2 variables. And now this is what we know how to do. Step 3, it says take those 2 equations and solve them just like you were before. So I'm going to rewrite them. Again, you could be putting these ideas together. I'll talk about that in a second, but I'm just going to rewrite them so you can see where they came from. So at this point, I have created a system of equations with only 2 variables, and I'm now going to solve. And you could solve this using elimination or substitution. I'm just going to stick with elimination the way it's set up. And so what am I talking about? Well, if I add these, nothing's going to cancel. So we're going to have to change some things. Once you guys get good at this, you could figure out what you need to change and then write it here rather than rewriting to rewrite it. But you have to be getting them right. So you could skip a couple steps. Your choice, do you want to get rid of the x's or the z's now? I would get rid of the z's because you already have one negative and one positive. I would also get rid of the z's because the common multiple is 10, the least common multiple, and here it's 12. So I'm going for smaller. So I'm going to multiply everything here by 5. That's going to give me a negative 10z. I'm going to multiply everything here by positive 2. And I'm just going to come right over to the side and do it. Make sure you distribute it to everything, especially the answer. Distribute that 2 to everything. And then you want to double check, do you truly have different signs here? Yes, a negative 10z and a positive 10z are going to cancel, and I end up with what? 23x equals positive 23. So what does x equal?
1.
X is 1. Okay, now I'm not done yet. I've got x. What else do I need to find? Z. So it says here, we have 2 variables, solve for those 2 variables. So I'm going to do that here. I've got x is 1. You can do whatever you want. I'm going to plug it back into one of the originals. So 3 times 1 minus 2z equals 5. If you want to rewrite it here, you can, or you could skip right to solving it. Show what you need to solve to get it correct. And what are we getting for z? I'm getting negative 1. Oh, I didn't know you couldn't see that. I'm sorry. So I just did the algebra. I've got x, I've got z. What else do I need? I need y. So we basically got it down. We eliminated down to one variable. We solved for x. Then we went back to one of the equations with 2 variables, and we found z. In order to find y, I need to go back to one of the originals. Now, it doesn't matter which original you use. I'm going to go back just to the first one. The first equation, I'm going to rewrite it because it's way down here. This was the first equation that we were given. And so I'm going to plug in my x and my y. So x is 1 plus 2y, x and z. 3 times negative 1 equals negative 2. Again, at this point, you could be skipping steps, but I'm going to show each piece here. Add like terms, don't cross the line, don't change the sign. And then I'm going to just subtract 4 and finish solving it. And I get 2y equals negative 6. Divide both by 2. And I've got y equals negative 3. Okay, so how do we write this answer? When you have an x, y, and z, it's actually a third dimension. So your answers are written in the order x, comma, y, comma, z. It's like an ordered pair with the third dimension. So we would write our answer as 1, negative 3, comma, negative 1, just like that. Now, how would I check this? Yeah, plug it into one of the originals, okay? When I plug it into one of the originals, since I used the first equation to solve for y, maybe I use the second equation. And if you really want to check it, you could plug it into both of the other equations. But I'm just going to plug it in here, make sure you're using the right variables. So I pulled the second equation from the original. That's where I got this from. And I do agree that 7 equals 7. So I'm happy with my answer. Again, you want to triple check or double check, then plug it into the third equation and see if you get a true statement. When you're checking, always go back to the original. All right, we're on example 2. We're going to use the elimination method. And the idea is that we have 3 variables and 3 equations. But we really only know how to solve when we have 2 variables and 2 equations. So our first goal was to pick a variable to eliminate and collapse it down. We're going to take these 3 equations and collapse it to 2 equations with 2 variables. So it's really your preference. Do we want to get rid of the x or the y to start with? I was thinking of getting rid of the x also, and here's why. I'm thinking if we pair these up, I can multiply this by 2, and the x cancels nicely. And then I'm going to pair up the first one and the last one, because I only have to change one thing. But you can do any combination you want. So let's pair up these 2. Now, I'm not going to do all the rewriting this time. I'm going to multiply this first one by 2. And so that's going to give me negative 2x plus 2y plus 4z equals 14. So instead of rewriting it twice, I'm just fixing it now. And then the second equation doesn't need changed. If it helps you to rewrite it, whatever works for your brain. Okay, so I've rewritten it, and we decided that we are going to eliminate, I should write that, we are eliminating x first. Okay, so I've done that, and that's gone. And I'm left with 5y plus 5z equals 15. So I'm going to come back to this. I'm going to go ahead and box this in. I don't want to lose it. This is one of the equations that I'm going to work with. Okay, if we got rid of x, we need to get rid of x again. So it's your choice. You could work with the second and third equation, and your common multiple, least common multiple, would be 6. So we're really using that same elimination method. I'm choosing to work with the first and the third equation. I'm going to write in purple, but I don't know if it's going to show up. So I am working with the first equation and the third equation here. And I'm going to multiply the first equation by negative 3 this time. So it's going to be a positive 3x, a negative 3y, multiply by 3. See, I got myself lost because I saw that. So positive 3x, negative 3y, negative 6z, and then a negative 21. If that's more than you want to do, again, just rewrite the equations. The bottom equation doesn't need to change because I chose to fix everything in the first equation to make it cancel. And then here we go again. We made the x's cancel, so we're left with y's and z's. So I have negative 7y minus 5z equals negative what? 17? Okay. So do you see now that I've cut it down to 2 variables? And then this is old news. If you want to rewrite these equations to stack them, you can. I just want to jump into elimination method, but what's nice about these, I already have a 5z and a negative 5z. So do I need to change anything to eliminate the z's? No. Now, let's say that didn't work. Then you might have to change. Like if I wanted to eliminate the y's, I'd multiply to get 35, 7, and 5. So I can just stack these. 5y plus 5z equals 15. So this is the old part. And again, you rewrite as much as you need to rewrite. So here it is. I'm going to add down. I prefer adding because I see it cancels the positive and the negative. And I end up with negative 2y equals negative 2. So what does y equal? Y equals positive 1. Okay, what else do I need to find? I need to find x and z. What should I find next? I can't find x because in order to find x, I need y and z. Agreed? So we're sort of working. So if you really think about this, we got rid of a variable, we got rid of x, then we got rid of z, and we got down to y. Then I'm going to go back. I'm going to take this 1, I'm going to plug it in here. So 5 times 1 plus 5z. I'm working my way sort of back up the ladder, if you will. I'm going to subtract 5 from both sides. 5z equals 10. So what does z equal? Z equals positive 2. Now, I keep doing that where you can't see. Now that I've got y and z, let's go back to that original equation. It doesn't matter which one. And I'm just going to go to the top one. It's negative x plus y plus 2 times z, which is 2, equals 7. Negative x plus 5 equals 7. I put my 1 and my 4 together. Subtract 5, I got negative x equals 2. Now don't forget, you can't leave me that negative x. So divide by negative 1, and what does x equal? Negative 2. Okay, so what is my final answer? X is negative 2, Y is 1, Z is positive 2. All right, how do we check it? Plug it in. Now, if I use the first equation to find X, I'm going to go to the second or third equation. So I'm going to go to the second equation. I'm just going to read it off at the top of my paper. It is 2 times X, which is negative 2, plus 3 times Y, which is 1, plus Z, which is 2, equals 1. So we're trying to see if it's a true statement. Negative 4 plus 3 plus 2. Does it work? Negative 4 plus 5. Yep. So I'm happy with my answer. I have checked it. Okay, so pause this video if you need to read this, but they've defined the variables. We know the quantity of tickets. There's 200 orchestra tickets, 30 mezzanine, if I'm saying that right, and 40 balcony. So I know the total numbers of tickets, and I know the total money in sales. They've defined the variables that X represents the cost. So X is the dollar amount of each ticket, Y is the dollar amount for these, and Z is the dollar amount for these tickets. So in here, we actually have our equations. If you can think about it, to add up all the money from Friday, it's 200 tickets times the cost. So if each ticket costs $20, there's how much total money they raised just on Friday in orchestra tickets. And then it'd be plus 30 times Y, plus 40 times Z. So if I would add up the money from each type of ticket, I would get the total money. So those are our equations. Let's pull that. We have 200X plus 30Y equals 40. Oh, sorry, not equals. What is it? Plus 40 Z. And that equals 1,470. All right, then we're going to do it again. We have a quantity of 250 times the total money, plus 60 times the money for each ticket, plus 50 times the money for each ticket. And that's our total money together. So it's all the money brought in from each type of ticket gives us the total. All right, third one, 150X plus 30Y plus 0Z equals 1050. Actually, that's pretty nice that we have 0Z. Do you see why that's nice? We already have one equation that doesn't have a variable. So when I say, hey, let's eliminate a variable, Z has already been eliminated. So I'm going to leave that third equation alone, and I'm going to pick at these top two, and what variable do I want to get rid of? I want to get rid of Z. Okay, what is the least common multiple of 40 and 50? 200. I was thinking about 4 and 5 being 20. Now, I'm going to change the top one by multiplying by 5. And if I change the next one by multiplying by 4, is that going to cancel? I don't think it's going to cancel because they're both going to be a positive. What do I need? Okay, so I'm going to choose to make this one a negative 4. Okay, so it might take a little bit of math, but we're going to rewrite these top two equations. And so I'm going to try to focus my brain here. I have 1,000x. I have 150y. I'm trying to double check myself. And then I have that 200z. And don't forget, we have to take the 1470 times 5. Did you guys get 7350? Double check me. Yes? Okay, fabulous. All right, we're going to take the next one by negative 4. Don't forget that negative sign. All right, here we go. We get, oh, well, that's nice. We get negative 1,000. Do you see why I'm saying that's nice? Minus 240y minus 200z. And don't forget to take 1950 times negative 4. And I have negative 7,800. Can you verify those numbers for me? We all agree? Okay, why did I say that was nice? Guys, not only did we get rid of the z, which we were planning on getting rid of, what else happened? The x canceled. So I don't have to pull. You know how normally we get two variables and we have to do it again to get two variables and then we solve? I've got it down to one variable right here. So I'm getting this as negative 90y equals, I want to check myself, yeah, negative 450. See if you agree with my numbers. And when I'm working with numbers like this, I'd be double checking myself. And then I'm going to divide both sides by negative 90. Now the zeros cancel, right? Negative divided by negative, I should get 5. So do you see that we got to skip a whole bunch of this? Normally we would have had to work with 2 equations to get 2 variables and then do elimination. Now I'm not done. All we got was 5. The 5 stands for the cost of the mezzanine seats. I still need to get X and I still need to get Z, right? So I know Y is 5. I'm going to go back up where I had this equation. I'm going to plug it in because I can use that. And so this would be 150x plus 30 times y is 5 equals 1050. Okay, so I'm using that bottom equation. 150x plus 150 equals 1050. Subtract 150. Boy, lots of same numbers here. I get 150x equals 900. Okay, divide by 150. What is x equal? Is it 6? Because 3, 3, and 3? Or 2, 2, and 2, yeah. Okay, that's x. What else do I still need, guys? Z. Okay, I can't use this equation to find z because there's 0 z's. So I'm just going to jump to the top equation. And I'm going to rewrite it way down here. 200 times x, which we know is 6. So there's the quantity times the cost. That's all the money on the orchestra seats. Plus 30 times 5. So that's all the money for the mezzanine. And we're trying to find out how much the balcony tickets cost. All right. So, get your numbers here. If we add up the 1200 and the 150, we should get 1350 plus 40z equals 1470. Okay, let's solve it. Almost there, but then we have some labeling to do. And I got 40z equals what? 120? Yes? Then what? Divide by 40. So what does z equal? 3. Okay, you can't just write this as ordered pairs because these have meanings. So what did the x represent? So what about the orchestra? $6? Yep, $6 per orchestra ticket. And what did the y represent? Money, so $5 for what? Mezzanine. I guess I should put tickets on here. Let's be official. And last, we found out that it was $3 for the balcony tickets. So we've got the work to back it, but notice that each variable represented something, and you almost have 2 labels, that it was dollars and what it was for. We want to check it. I would take these 3 x, y, and z values and plug it into one of the equations that I didn't use at the end.